we go. 0 to square root. dA. dy dx. All right, so a really good first step is to...
What exercise is that?
Oh, 32 and 15.3. This is what I'm talking about, right? Okay. If I sketch this out, what will it look like? Well, one good place to start, like again, I think one of the weirder parts of this problem is that, possibly. I don't know.
This is a sphere.
No.
Or circle.
Yes. So this is saying as x goes from 0 to 2. Now, what do you guys know about this? Well, at 0 it's 0, and at 2 it's 0. But just to be sure about exactly what this thing looks like, you know, I don't know if this is the center. That's the center that I know certain things about this. So this is y equals this, right?
Yeah.
So y squared plus x squared equals 2x. Is that cool?
Yeah.
Whatever. Is that cool? Okay. And then x squared minus 2x plus y squared equals 0. So then you can complete the square here, right?
Yep.
So I had to add 1 to make this work. So its center is at 1, 0. That's cool to know. So I know this is the center. And at 1, where is this? Well, you should know where it's going to be. What's the radius? We know what the radius is, don't we?
Radius is 1.
Yeah. So since that's the center, and it's 0, 0, 2, 0, and 1 it's going to have to be. And sure enough, you plug it in, 2 minus 1 is 1, square root of 1 is 1. Yeah. All right. So I know I overanalyzed the hell out of that, but when you have a limit that looks like this, just take a minute and look at it. And the whole point of this problem is to convert to a different set of units. So you want to start getting used to just quickly sketching out what this thing looks like. We did that before. It makes it so much easier to change units when you do that. Oh, we'll just move on. So now so parts of this are simple. But now just forget about this shit. Now here's the region we're talking about, right? So now I want to identify this region using r and theta. So what does r go from to?
0 to...
0 to... What's it always go from to?
To the edge of the... whatever that is. That's a cosine?
Yeah, so what can you do?
Is it 2 cosine?
So the definition of this is x squared plus y squared equals 2x. So how do you convert that into polar? X squared plus y is r squared.
Equals 2 cosine. Yeah.
So x equals
Cosine.
2 cosine theta. So remember, cosine likes x. So if I have r equals something cosine, it's going to be a circle on the x-axis, center on the x-axis. If I had r equals something sine, it's going to be on the y-axis. If I have r equal to a combination of those two things, it's going to move diagonally, both directions. I like it. Yes. Are we? You guys get that? So what's r going from to then?
It's from 0 to 2 cosine theta.
Yeah, it goes from 0 to the function, which is this function. What's happening? Do you guys see how I got there? I needed this in terms of r and theta. So I took the definition of it in x and y, and I converted it to r and theta. Not a big deal. But I wanted to sketch it out and then work with the function directly. I want to do those things for myself, so I always have something to kind of look at to make sure that it's all making sense. So 0 to 2 cosine theta. And what is theta going from to?
0 to pi over 2.
Yeah, it looks like 0 to pi over 2. I like it. And of course, cosine of pi over 2 is
0.
0. So it goes from 0. Cosine of 0 is 1, so that's 2. So pi over 2, that's why it comes back to 0 there. It makes sense. Again, checks and balances, make sure that it makes sense. So it does go from 0 to pi over 2. And then what do I put inside? R. Its own R. This is part of the dA, and that is the function that I'm working with. Whew. So real quick, What does this thing look like above this? At 0, 0, where's the ceiling? It actually is where? Do this. So remember, this is the definition of the ceiling. So at 0, 0, it's at 0. Because what's R at 0, 0? 0. So as I move away from that point, my ceiling goes up linearly with R. Okay, good. I like it. But you see how it's smart to kind of look. So where's the ceiling the absolute highest? At this point, yeah. Because that's the biggest R can be. If R is in here, it gets smaller and smaller and smaller. Do you really have to be able to do what I just said to get this problem? No. But if you're able to think about it that way, then some of these things make more sense. So now that's easy to integrate. Is that cool? Which problem? Oh, yeah. 32.
Could you do 28 in this section?
The thing to realize about 28, they kind of give it away a little bit. I think at some point they talk about like a ring. Have you guys ever seen those thick class rings? So there you go. Well, yeah. Well, I'm talking about the thick ones, you know. So looking at it, if I were to bore through this sphere this way, and this kind of makes it look like it's these parts are going to fall away. But remember, I can't really do 3D well. This is repeated around, just like when you open something up. Remember, so this is repeated all the way around. So that's one of those thick ass class ring. If you ever seen those before. Sick. Yeah. So this is the shape we're dealing with, right? Okay. So for part B, it's all going to be about the height. What they mean by the height is this height. Somehow you want to incorporate the radii of the two circles.
Well, that's big. So when I did this problem, I tried doing it in polar. So you do it from one radius to the other radius, and then you go from 0 to 5, and you do the whole thing. But my problem was you have like two different, because it's a sphere. I was having trouble with the fact.
Plus, it's used to bore a hole through the center, so it's. What am I going to do? Don't I want to? If that's the only problem you had trouble with, don't worry about it. I'm not going to pull one like it. I'll write up if somebody will remind me, I can write up the solution to this for you. But this one was neat because it's not a stationary thing. I'm taking another sphere and boring it through this one. So it's all about what the resultant shape looks like. So if you look at it straight on, instead of this, that's not a moon. If you look at it straight on, where this thing went through, then it's going to have this, right? That's looking straight on at it. Okay, I like it. And it just goes through it. It's a little bit funkadelic. But you got to be careful. It's not like a sphere inside of another sphere. It's a sphere that's bored the way through the inside.
So, like, you would subtract them to find the area between them, but you'd have to have like a cylinder.
So you think about this as being a cylinder. You find its volume and subtract it from the volume of the sphere. I mean, that's probably the best way to do it. Because this is not going to be spherical inside at all, right? It's going to be cylindrical.
Okay.
So there's a few different ways to come at it. Okay. I haven't really decided which way I want to come at it, but we'll see what I end up doing. You could? You totally could?
Or you could try to do
You can do this one without integrals?
No. Well, probably.
Subtract some.
Let me think. You probably... Yeah, you could. Yeah, you totally could. Yeah.
Well, couldn't you do disc and washer?
There's a little bit of things you got to be careful about, but... What?
Disc and washer? And
It's very rare that I hear a student actually suggest that as an alternate way to do something. So I appreciate that on that level, Jesse. Normally it's all about, please to God, let that be in my past. But yeah, there are problems where that actually makes it easier. I don't know if this is one of those, to be honest. All right, but don't worry too much about it. I just want to give you one that was less set up for you, is more completely, this just happened in the real world. Use calculus to figure something out about it. So that's definitely one of those much more difficult problems, yes. If you guys managed to do it.
Number 12.
Oh, 12 won't be on this next test. Remember, it's I'm only going to have a triple integrals already set up for you, where the limits are already set up. Because there's considerations for triple integrals. There are so many different ways to reformulate it. Yeah, I'm just getting like that very last problem on the handout we did the other day. That triple integral that was already set up. So I mean, that should be no problem. If it's already set up, you should be able to attack it. And the first like 6 problems in the homework from 15.6 are all like that. They're already set up triple integrals. Yeah. So that's the practice I would do if I were you. But it shouldn't be too big.
First 6 problems of 15.6.
Yeah, well, yeah.
We have a math test on Wednesday.
Like 3 through 11. Yeah.
You have a week, right? You have 5 days. 2.5 those.
You guys voting tomorrow? Or anybody already voted?
Male voter.
I didn't mean to upset you. John, what are you implying? Oh, all right. I like to go, especially because I have time on Tuesdays to get out there early. If I could only get there at later or early in the morning, I would never vote at a freaking polling center. Standing on those long ass lines. Huh?
It was like an hour. Same way you're waiting that many
Male voting is the way to
I don't know,
go.
just something about it. I like to be there, and I like to see, especially this year, I want to see what else.
Okay, if you really want to, you can mail vote and then take it in person, and you walk to the front of the line, drop it in, and they give you the sticker. You don't have to wait in line.
Yeah, that's what I did for the other one.
I don't care. I just like the whole thing of it.
I had no idea how to do
Well, it's more of a
Maybe get food.
Yeah, okay, good. So this is oh, yeah, okay. Alright, so that's this picture here. Just place them in the right place.
Yeah, I was thinking something like that, so then that would be... Yeah,
So you put your radii. You want to put this radius right there where I cut off the top part, because if you try to do this, it goes too far, right? So you put it right there, and that actually lines up perfectly with half the height.
Okay, so then how the hell would I integrate that? Compare to other ones.
No, all it's saying was,
What's your...
what was it asking? Yeah, it's just rewrite the previous expression. The answer to part A, rewrite it in terms of H only. I think is what it said, right?
Okay.
Let's see if I'm right. What'd you get for part A?
I got 435 times r squared minus, well, r2 squared minus r.
Beautiful.
Yeah.
Yeah. So what's R2 squared minus R1 squared right now?
If I got that...
Equals 1/2.
Yeah. No, Jesus.
You're done? You're done? Oh, I'm sorry. I gave away too much.
That is frustrating.
He was halfway there, that's why I went further.